So you'll be, week 6, you'll have the group project 1 first half will be due, which is basically the main aspect of this is you'll be writing the introduction section for group project 1. And I believe I'm going to have you write a little bit of the methods as well. Data collection, which will require at least 8. I think every group has at least 4 group members, and 2 times 4, 2 participants per group member means all groups, I believe, will be collecting data from 8 participants, and that will be due Sunday. I believe it's October 4th. I have, over the weekend, and I mentioned I was going to do this last weekend, I have put up a very detailed information regarding data collection for group project 1, and it's right here. In particular, this document right here, group project 1 data collection. I'll go ahead and click on it. Very detailed. I have links to several videos and demonstrations, Google Sheets. There's a lot going on in this. This is definitely really, really important. And I could not imagine you being able to finish group project 1 without giving this a close read. So there's a whole lot going on here. Definitely take a look at this. This explains basically in detail what we're going to be doing for group project 1. You kind of already know, I've told you that we're going to have one group listen to Mozart music and then perform the Stroop task. And then we're going to have another group do a control condition. And I decided over the weekend, I spent $6 and bought a CD called Calm Sound. And I used one track. So it's just like, you know, sounds of like nature and stuff. They're supposed to be calming. And in particular, one track called Rain Chimes. We're going to be using that as a control condition. It's calming sounds will be used as the control condition, but there's no music. I see a chat here. Let's see if that's for me. Yeah, so one person asked where you find the participants for the study. And that is also addressed on here. Everyone that you'll be running will be on Sona system. So that's why you are getting your researcher account. I'm trying to see where it talks about researcher accounts. Yeah. Participants will sign up for time slots that you post on Sona. You have to use your researcher account to post time slots. So you will be using Sona to do that. And then the participants will, just like if you took 104 here, you signed up for experiments that you were a participant in when you were an intro student here. Now you will be creating the time slots that other people will be signing up for. So you'll log into your researcher account and Sona to do that. If you need some help figuring out how to post time slots, I would be happy to help. Maybe I can remember on Wednesday to give a brief demonstration for how to do that. Yep, Psych 104 students is correct. Those will be your participants. Okay, so there's a lot. Please read this. This is like super important. And I spent almost all day doing this yesterday. So I spent a ton of time trying to make this like perfect. And I think it's pretty darn good. And you'll probably have some questions. I'd be happy to answer them. This is definitely important. You're definitely going to want to read this closely. You're going to need to watch some of these videos. One of the things I show in this is, I basically show you the entire code for the experimental condition. You're gonna have an experimental condition where they listen to Mozart inside Toolkit, and then you're also gonna have a control condition where they listen to rain chimes. And I've shown you how to code the experimental condition. You're gonna have to kind of figure out how to code the control condition by yourself, but it's basically the same as the experimental condition, except in the experimental condition, wherever you see the Mozart music, you're gonna replace that with rain chimes. Everything else should be the same. And I've showed you in great detail. I've show a video of the entire code for the experimental condition and lots of information regarding how you'll do that. But I still think it's one of the more challenging aspects of this course will be coding your own experiments inside Toolkit. And so I would not procrastinate on this. You have 3 weeks to complete data collection. You only need to get eight participants per group. Most groups will only have to get 8 participants, but I would not procrastinate. I would start figuring out how to code this using this information on this document right here and the videos I've included. I would get started as soon as possible. I would not procrastinate on this. Any other questions or comments? Yeah, so once again, this is This is available on Blackboard. This is in group project 1. There's already the thing about the Zoom group recording. You're going to be turning in 2 different things for data collection right here. You're going to be turning in a Microsoft Excel document that's going to have all of the participants that you run. Each will be a separate tab, separate sheet, kind of like what we did in lab 1 and 3. And then here you're going to turn in an entire folder that has the raw survey and data files. So this, you'll be turning in the raw data files and then the compiled data files, what you do in Microsoft Excel. And that will be for the 15 points that you'll get for data collection. Later this week, I will also be posting detailed information about my expectations regarding the first half paper that you're going to write. So you're going to write, group project 1 is going to be 2 halves. There's a first half and a second half. The main part of the first half is the introduction with a couple other things. The main part of the second half is the results and the discussion. And I will give detailed information about my expectations regarding the first half. That is mostly the introduction, maybe a little bit of methods later this week. So once again, I'll add any questions or comments about group project 1 or anything that I've been talking about today. Okay, let's see. So there's that. Next thing is, oh yeah, just I guess the stuff for today. Here we go. So you read an article for today, Probe Tone 1, which we're going to talk about that, and we're going to talk about a related article, which I didn't have you read, but it's kind of similar. And then the article that you read for today, Probe Tone 1, is related to this idea of tonal expectations and tonal hierarchies, which are relevant in music perception literature. So we'll talk about these 2 topics, tonal expectations and the Probe Tone 1 paper. They're kind of combined, they're kind of related. And then we will also talk about the analysis for lab 3, which also concerns tonal expectations. So really everything today is kind of about tonal expectations, music perception. I'll introduce some concepts. We'll talk a little bit about the paper that you read for today. And then we will talk about the lab 3 analysis so that you can begin part 2 of lab 3, which I'll tell you will be due Friday. I've already posted that on Blackboard. It'll be due Friday, and I'll tell you more information about what you'll be doing for that later on today. So just some conceptual things. A lot of this stuff that I'm going to talk about here, you should have obtained, you should have read about in what I had you read in the Probe Tone 1 article. If you recall, for the Probe Tone 1 article, I asked you not to read the entire thing. I really only wanted you to read a part of the introduction. The reason I had you do that was because this stuff in music perception has a lot of language and terms that you might not be familiar with unless you're a musician. So I wanted to make sure that you had a little bit of a reading to give you some background. We're not going to be going in super detail about these terms and concepts, but you need to understand these terms and concepts well enough that you're going to be able to perform the statistical analysis part 2, lab 3 part 2, which I'll get to later on. So yeah, I'm going to just kind of review some of the things from the introduction section of the article, going into a little bit more detail in some places here in the next few minutes. So tonal expectations and tonal hierarchies. Tonal expectations is the idea that when people are listening to music, they kind of make predictions about what the song is going to do in the near future. And for everyone who's already taken lab 3, which is the super majority of the class, you were probably forming expectations when you were listening to those melodies in lab 3. I'll try and sing here a little bit. The do, re, mi, fa, sol, la, ti. And then that might have felt what I just sang like it was incomplete sounded, like I'm missing a note. And that last note would be do. That's the note. I kind of delayed that singing that note. And until I sang it, you were expecting me to sing it. That final last note, do, which kind of completes the melody. And that same melody was used in lab 3. And what lab 3 was investigating was, do people form expectations for that final note, do, in the melody? And I'll give a little bit of foreshadowing. Yes, our class most certainly did, on average, show the expected effect regarding that. When people are listening to melodies, when people are listening to music, they tend to form expectations. What pitch should occur here in the near future? What pitch am I expecting to be the next note or the next few notes or the next chord in a song that I'm listening to. And so the basic idea of tonal expectation theory is that when you expect a pitch to occur in a song, like that do note that I just sang, that note sounds, the terms which is usually used is stable or relaxed. It's kind of, or another term would be like restful. When you hear that do, it sounds like ah, and you're kind of relaxed or stable or feeling rested, compared to other notes that might occur at the end of a melody, which if they're not the expected note, if they're a note which is not expected, those notes will sound, as the terms are used here, unstable or tense. Oftentimes those unexpected notes will be described as increasing musical tension. And the scale or the notes that we were studying most in Lab 3 and which have been studied in music perception literature in general are the Western major scale, which is the melody I just sang. Do, re, mi, fa, sol, la, ti, do. That's the Western major scale. It's a collection of basically 7 notes. And I say, and this is not an exaggeration, if anything, it's an under-exaggeration. Hundreds of thousands of songs are composed using that exact collection of notes right there. Those 7 notes, do, re, mi, fa, sol, la, ti, do, just in different orders and playing some notes at the same time instead of just a single note at a time, basically is the basis for, I don't know, like 90% of all music which is composed in the West, you know, in the United States and other countries that are considered part of the West. And so it's a very important set of notes because so much music uses it. You don't even realize it, but like almost every single pop song you've ever heard uses the Western major scale, just those notes, just in a different order. And I've written it here, do, re, mi, fa, sol, la, ti, do. So I said there were 7 notes. If you actually count 1, 2, 3, 4, 5, 6, 7, 8, there's actually 8 notes here. But the reason I only say 7 notes is because you notice that the note do appears twice. And so I don't count that twice. I only count it once. And so the do note is, for any given major scale, the do note is the note that the major scale is named after. So if I say the C major scale, there's a bunch of different scales. There's the C major scale, or there's the D major scale, or there's D sharp major scale. There's a whole bunch of different major scales. They're all do, re, mi, fa, sol, la, ti, do. The only difference is the starting note of that scale. If I say the C major scale, that starting note is C. If I say the D major scale, that starting note is D. We will only be dealing with the C major scale. It's just the simplest example. And I'm not trying to make you guys music theory experts or anything, but you should understand that C major scale, the starting note, the note do, is the note C. And you can see it right here, the notes in the C major scale. C, so do, re, mi, fa, sol, la, ti, do. Right there, there's the C major scale. And so in the C major scale, all of these notes are natural, meaning C natural, D natural, E natural, F natural, as opposed to sharp or flat. There are no sharps or flats in the key of, or the scale of C major. In case you're rusty with what sharps and flats are, this is the note, the C major scale are the black letters right here. Do, re, mi, fa, sol, la, ti, do. So that's all the notes. The black ones are all the notes in the C major scale. But in between are a bunch of other notes like C sharp, D sharp, F sharp, G sharp, and A sharp. I guess that's 5 notes there, which are in red. Those are, in the C major scale, there's only 7 notes, but that's not all of the notes that can possibly exist in music. Usually in the West, there's actually 12 total notes that possibly exist. There's the notes which are in the scale, those 7 black notes, but then there's notes that fall outside of the scale, which are the black ones here. In the key of C, the red ones here are the ones which fall outside of scale. And in the key of C, all of the out of scale notes are sharp. So C sharp, that's out of scale. D sharp, that's out of scale. All these red ones fall outside of the C major scale. They're notes that exist, but they're notes that if you're listening to a song which is in the key of C, the scale of C major, you're unlikely to hear these songs because they're out, or these notes because they're outside of the scale. The term, which was used in the article that you read for today for these notes, non-diatonic notes. Questions or comments so far? All right. So we've already mentioned that in the scale of C major, it's the first note of the scale, the do note is C. That note is referred to as the tonic. So in the scale of C major, C is the do note, do, re, mi, fa, do is C. And that same note, do, C, is also referred to as the tonic. It's considered kind of like the starting point of the scale. Or in the article that you read for today, they called it like the reference pitch for the scale. All other notes are kind of evaluated by your mind with respect to the tonic, which is kind of like the root pitch or the most stable pitch in the scale. So for a long time before people were doing music perception research, there were music theorists, and they would basically say, yeah, the tonic note is the most stable note in the scale. It's the note that when people hear it, they expect that note to occur. It's the one that feels, when they hear the tonic note, that is C, the do note in the scale, it's the one where they feel most relaxed. It's the one that feels most stable. You feel most restful when you hear that do note C. And so the tonic is the most stable note according to music theorists. And then there's also been research, what we did for lab 3 and what you read about some for today, which kind of supports this idea that indeed, when you ask participants to rate how stable different notes sound to them in a melody that they just heard, the tonic is usually the one that gets the highest ratings. It's the one that people perceive to fit the best with the previous melody, to be the most stable note relative to a previous melody that they had just heard. So the tonic is the most stable note. So that in the scale of C major, in theory, and according to behavioral research, the note C is the most stable note in the scale. And then the other notes in the scale, so D, E, F, G, A, B, and C, those notes are relatively less stable than the tonic, according to theory and behavioral research. And then non-diatonic notes, those are the notes that were read previously. Those notes are perceived as less stable. And so what's nice about this is that music theory, which has existed for like a long time, people were writing about this stuff theoretically, kind of agrees with what the behavioral research says. So the music theorists made predictions, and then some years later, those predictions were tested with behavioral psychological research, like what you read about for today and what we did in lab 3, which basically supported a lot of the predictions that the music theorists were making. So this takes us to the probe tone method, which is what we did for lab 3. And you might have noticed that we were listening to basically just 2 melodies in lab 3. There was the ascending major scale. That's the one that I've been singing all day. The do, re, mi, fa, sol, la, ti, do. And then there's also, it's called ascending because it's starting at a low note and it's going to a high note. And by the way, these numbers here, the 3 just means that these notes are lower than the 4. So each note on a piano has a number. The really low notes would be like C1, and then the really high notes would be like C4, C5, C6. So the notes that we were using are in the middle of the piano. C3 is a low note, and then once we get to C4, that's the next octave, or that's a higher version of C. So that's a low C, and that's a relatively higher note C. So low in pitch going to relatively higher in pitch. That's the ascending major scale, compared to the descending major scale, which would be do, ti, la, so, fa, mi, re, do. So do, ti, la, so, fa, mi, re, do. Starts with the high note, and then it gets gradually lower. So these are the 2 melodies that we heard, and you heard, piano playing it in lab 3. But these are the 2 melodies, the ascending, the up major scale, and then the descending, which is the same notes as the major scale, just basically in reverse order, starting at the top, starting at the highest, and going down to the lowest note. Those are what we heard for lab 3 today. And those were common melodies that have been used in behavioral research. The probe tone method is exactly what we did in lab 3. And there's been 2 really foundational studies. These are highly cited studies. Carol Krumhansl, last thing I knew, she was a full professor at Cornell University. She gave the keynote address at the Society for Music Perception and Cognition several years ago. So she definitely is pretty famous in the field of music perception. She's also written a book about this topic. So she kind of invented the probe tone method, and it's still used today a lot, actually, by music, 40 years later, basically, and it's still used a lot by music perception researchers. So the paper that you read for today was Kessler and Krumhansl, 1982. There's also another one that I didn't have you read, that we're going to talk about the data from this one, Krumhansl and Shepard. Both of these papers use the probe tone method. You just read about the introduction to give you background on these concepts from this paper. Today, I'll be telling you a little bit about some of the findings and stimuli that were used in this paper right here. But in general, for both of these papers, the way they use the probe tone method and the way the probe tone method works is the participant listens to a context, and the context can be one of several things. It can be a melody. That's what we had for lab 3, and that's what I've been, my little singing today. Those have just been simple melodies. Or a series of chords. And a chord, which was defined in the paper you read for today, a chord is basically just multiple notes that are played simultaneously. So you can have a melody is just a series of individual notes, or you can have a series of chords which are played simultaneously. That can be a context, and that's used as a common context in studies. Or some studies will just use a single chord which is played. Those contexts are always composed using whatever scale you're interested in. Usually it's the major scale. The context where the melodies or series of chords or just an individual chord, all of the notes in the context are drawn from the scale that you as a researcher are interested in studying its properties. The probe tone method gets its name though from this last part right here. And we had this for lab 3. The participant hears a single pitch. So we heard a melody. Do, re, mi, fa, sol, la, ti. And then there's a pause. I gave you a 1-second pause. And then you would hear a note after that. And the note would be, there's different notes that I would play at the end, or that I would have SciToolkit play for you at the end of that melody. And your task, if you remember in lab 3, was rate how well the probe tone fit with the context on a scale of 1 to 7, where 7 means the probe tone fit very well with the context you just heard, and 1 means it did not fit well with the context you just heard. And in the lab, I encouraged you to use the full range of the scale, so 1 through 7 and all of the numbers in between. This is the most common way that researchers have measured how stable participants feel that a note is. We talked about that idea of stable, the idea that the tonic is perceived to be the most stable note in a given scale. Because stability is kind of a difficult concept for participants to understand, usually instead of saying how stable was the pitch that you just heard, instead the language that researchers use is how well did the probe tone fit, which is a more kind of basic word than stability, which how stable was the tone, which is a little bit more complex. This language is used because it's thought participants would understand it better. But what this is meant to be assessing is how stable do you perceive that note at the end to be relative to the melody that you just heard, the context that you just heard before it. So this is just more information. I copied and pasted this from Krumhansl and Shepard, 1979. So you didn't read this one, but it's basically giving the same information that I just talked about. It's showing it in musical notation format. You probably learned how to read music in third grade or whatever in elementary school. So you might be rusty about this, but you still can kind of see it. The descending context, it starts high and the notes get low. The ascending context, it starts low and it gets high. And then they call in final notes here, but these are just the probe tone. When I was in the lab 3, after you would hear each melody, there's 13 notes here. These are all of the possible notes that could just possibly occur. Some of these are in the C major scale. Some of them are non-diatonic notes like C sharp, D sharp, F sharp, G sharp. Those are the notes that are not in the scale. After that melody, you would hear one of those 13 notes and you're asked to indicate how well did that note fit with the context, with the melody that you just heard. And this is kind of this is the data. So this is taken from Krumhansl and Shepard. Basically for lab 3, we did basically almost a direct replication of the 1979 study. So once again, I didn't have you read the 1979 study because, well, it was an earlier study and they didn't, you can kind of tell by reading it, they didn't really understand conceptually what they were doing at the time. They had very great methods, but their writing about it was a little bit confusing, to be honest. And I didn't want you to read a paper that would confuse you. So I had you read the 1982 paper because their thoughts were more collected by then, and they were able to write about things in a way that, at least in my opinion, made more sense. But the findings that were most relevant to us are from the 1979 study, because this is exactly what we did for lab 3. We had an ascending context, the do, re, mi going up, the descending context, the scale going down. And then you heard at the end of that, each of those melodies, you heard one of these 13 pitches, and your task was to indicate how well that pitch fit with the melody you just heard. And you get this profile right here is what they got in Krumhansl and Shepard, 1979. And they got a very similar one, by the way, when they replicated this in the paper that you read for today, the Krumhansl and Kessler, 1982. I mean, the most important thing to note here is that the notes that are tonic, C is the tonic note, and then you have C again because you have the low C, and then you have the high C. Those are both the tonic. Those are the do of the C major scale. And if you see in the results here, these are the notes, C, that received the highest ratings in Krumhansl and Shepard, 1979. C got really high ratings here, and C got really high ratings here. And it doesn't really matter whether it's the ascending context or the descending context. The note C gets the highest rating. And then you kind of see the second tier of the hierarchy. Part of the reason the word hierarchy is used is because the tonic is thought to form the top of the stability hierarchies, the note which is most stable. And then there's the other notes which are in the scale, but are not the tonic. So that would be like D natural, E natural, F natural, kind of considered stable, G natural stable, A natural, and B natural. Those are all the in-scale notes. Those are the ones that are perceived second most stable. And then the least stable notes, and it's quite clear here, is by looking at like the C sharp, that's really low. D sharp, really low ratings. F sharp, really low ratings. G sharp, really low ratings. A sharp, really low ratings. So there's kind of like a 3-tiered hierarchy. The tonic is the top of the hierarchy, the note C, do. Then all of the notes that are in the C major scale that are not the tonic, that's the second rung of the hierarchy. They're second most stable. And then the least stable, those pitches which are outside of a scale, those non-diatonic pitches are perceived as least stable, are at the bottom of the hierarchy. And you can see all that in the data. And really the question I had for us for lab 3 is, would we replicate this? And yes, we absolutely did. Our hierarchy looks almost identical to this. I will say our tonics are a little bit lower than theirs, but I don't mean to jump the gun. I will show you those graphs here in a second. So we're getting towards the data analysis that we're going to do for Krumhansl and Shepard, and I want to kind of assess first off what they did to analyze the data in these studies, but then what they should have done. And I say that right here. Their paper was published 40 years ago, and although Krumhansl is definitely famous, full professor at a very prestigious school, back then the standards for statistical analyses were different. They were less stringent, and so they did some things that today I don't believe would get past peer review. And I'm going to point some of those things out. And in our statistical analysis, we're going to make a couple improvements compared to what they did, and I'll be very clear what those improvements will be here in a second. First, I just wanted us to kind of think about what the factors are here. So first off, one of the factors is the name of the probe tone. And this is a factor with many levels. We have 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 levels of this factor. And it's the x-axis of the graph I just showed you on the previous slide. Another factor is the type of context, the type of melody, which is either the ascending melody or the descending melody. And then a potential other factor would be kind of the different rungs of that hierarchy. The tonic note, all of the other notes which are in the scale but are not the tonic, And then finally, the out of scale notes, those notes which are non-diatonic. So these are three potential factors. And so if we have three factors, the appropriate statistical analysis would be a factorial ANOVA. These days, that's probably what a researcher would have to do in order to get this published. But that is not what they did. They did several things statistically, which today would just absolutely, I do not believe would pass peer review. So they should have performed a factorial ANOVA, but that's not what they did. Even though they have those three factors, they kind of combined the ascending and descending conditions to, they combined them. Basically, they took the average of those two. So by doing that, they basically got rid of the factor type of context. They took the average probe tone rating for the ascending and descending conditions for all the different notes. And basically what that did is it completely eliminated the type of context, the type of melody as a factor. And I'll give you more concretely what that means. I'll actually show you what they did statistically here in a second. So they got rid of that factor, and then they also kind of ignored in their statistical analysis, they ignored this factor, and they also ignored a type of probe tone. So even though they had these three factors in their statistical analyses, they basically completely ignored these two. And really the only one that they used was this one. But even the way they did this one was some sketchy things. And the thing that did it was sketchy is they went straight to a post hoc t-test. So post hoc t-test, they shouldn't have done that. They should have run an ANOVA first, but they went straight to a t-test. We are going to do those t-tests again. But we're going to also do the ANOVA. So what they should have done, if they're going to ignore all those factors, which I don't necessarily think is a good idea, they should have at least done a one-way ANOVA. And what that one-way ANOVA would do would be, among all these 13 notes, C natural, C sharp, D natural, D sharp, all the way through, from C, the lowest C note to the highest C note and all of the notes in between. Are there stability differences among those notes? Do participants perceive those notes to vary in stability? That's kind of the omnibus test. That's what you want to know before you're able to dig in to those post hoc t-tests to kind of look at the details they are interested in. The first thing you're supposed to establish is, yes, overall there is a difference. And then you're allowed to go into the post hoc test to look at the individual things that you're interested in. But they went straight to the post hoc test. We're going to do those post hoc tests, but we're going to do the appropriate, a somewhat more appropriate analysis. We're going to do the one-way ANOVA, and then assuming it's significant, which is super, very, very significant, then we will do the post hoc tests that they also performed. Here is those post hoc tests, and though this is the statistical analysis, once again, you didn't read this for today, so I'm posting it here. They did 2 t-tests, and they're shown right here. So the low and high Cs, those are the tonic notes all over all other notes. So they did a statistical test comparing the probe tone ratings of the tonic notes, that is the low C and the high C. They compared the probe tone ratings for those 2 notes to all of the other notes in the hierarchy. And they did a t-test to compare those, and it was significant. So the tonic note is perceived as the most stable compared to all of the other notes. And they also did another analysis where they were comparing all of those in scale notes other than the tonic. So all of those notes that are in the scale but that are not at the tonic, they compare the probe tone ratings to those to all of the non-diatonic notes, that is all of the notes that are out of the scale. And they found that there was a significant difference. That is, notes that are in the scale but are not the tonic are perceived as being more stable than those notes that are outside of the scale. So both of those differences were significant. We are going to replicate both of these t-tests for Lab 3 analysis part 2, but we're also going to do the one-way ANOVA that they should have done. They should have done a factorial ANOVA. They didn't do that, but they didn't even do the one-way ANOVA. We're going to do the one-way ANOVA, and then we'll do these post hoc tests right here. So getting to the actual Lab 3 part 2, this is what you're going to be doing. I posted a video. The announcement is available currently on Blackboard, and I show you exactly how to analyze to perform these 3 statistical tests. So 1, 2, and 3, I show you exactly in SPSS. You're gonna have to do this in SPSS. I show you exactly in that video. It's already there on Blackboard. You can watch it whenever you want, as many times as you want. You're gonna have to do these 3 analyses right here. But you're gonna have to prepare the data a little bit, and that's what these other bullet points are. And I'll show you how to do this. First, you're gonna have to combine scores, which I was talking about previously a little bit. Combining scores, which basically means calculate the average for each note between the ascending and descending conditions. Remember I said in these previous studies by Krumhansl, when they were doing statistical analysis, they collapsed across the 2 different types of melodies. They didn't really care about the difference between the ascending and the descending melody in terms of how that influenced probe tone ratings. So they just combined all the probe tone ratings from these 2 different melodies into a together, and we're going to do that. We're going to take the average of each probe tone rating for each note between the ascending and descending conditions. So we'll get a single probe tone rating for each note. So instead of 26 scores per person, which is what we originally had in the Google Sheet, we're going to simplify that so we only have 13. Then we're going to analyze those 13 means with the ANOVA. I show you that in the video. Then we are going to do the first post hoc test that they did in Shepard and Krumhansl 1979. So what they did is they combined the scores, the probe tone ratings for the 2 tonic notes, the low C note, C natural, that CN means C natural. That's the low C natural. And then the high C, these are our 2 tonic notes, the low one and the high one. You combine the probe tone ratings for the low and high notes. And then we're going to combine, take the average of the probe tone ratings for all of the other notes, excluding those 2 tonic notes. And we're going to do a t-test, which compares those 2 means. That's the first post hoc test that they did. Then we're going to combine scores for all of the in-scale notes that are not the tonic. Okay, calculate the average for all those notes, excluding the tonic, for the in-scale notes. And then we'll do the same thing. We'll calculate the average for all of the non-diatonic notes. Those non-diatonic notes are the ones that earlier I showed you, those were in red. They all had, in scale of C major, those all have sharps next to them. And so we'll replicate that with the t-test. So I'll show you exactly how to do that now. So you have, let's see. This is the Google Sheet that we have from Lab 3. And so far, 25 people have submitted their data. I will point out, though, that 26 people actually had originally submitted the data, but one participant number 30, put values here in the B and C columns, but then the rest of the columns were blank. So instead of just having partial data there, I erased all of those. And if that person wants to, they can figure out why they only copied and pasted 2 data points here instead of all the rest. But I erased them because the partial data would make the analysis a little bit confusing. There's also a couple other things. Yeah, this participant also left one blank. That's, what participant is that? Participant 18 left that one blank. I couldn't figure out why that one was left blank. And then right here, I left this in there, but 0 was not even one of the options of possible scores that you could give. So I'm not really for sure how this rating of 0 got in here, because Size Toolkit won't even recognize the number 0 the way I programmed it. So this has to be a typo or something. I just can't imagine how that's a 0. I'm curious to know how that got there. So there was a couple anomalies in the data that some of you guys provided, but we're going to analyze the data anyway with some of these anomalies. So this is what the Google Sheet from Lab 3, this is it right here. So these are all of the data you'll need to use this Google Sheet. And then here's what I've done. So you do not have access to this, but this is where I show you how to do the calculations for this stuff right here. First thing, combine scores, calculate the average for each note between the ascending and descending conditions. So here's the note C natural 3 right there. And if you look here at the formula, the average of B2 and O2. So let's see what's in B2 and O2. D means descending, C natural 3, and then, oops, I can't see anything there. And then we have the number 6. So this is, for the descending melody, this is participant 1 provided the note C3, that is the tonic note, the low tonic note C, a probe tone rating of 6 out of a scale of 7. So this participant perceived that note to be very stable. The other one was, I believe, O2 that we took the average of. So this is up. That U means up. I could have put ascending, but I just did it. D means down, U means up. Once again, though, it's C in 3, C natural 3, so it's the low tonic note. And that note was perceived as a 5. So this person rated it, once again, pretty stable, not quite as stable as the other, as the same note in the other context. But we're taking the average of those two numbers. 6 plus 5 divided by 2, the average of those two numbers is 5.5. And you do that for every single participant for every single note. So let's go to C sharp 3 right here, the average of C2 and P2. So this is the average for this one participant that they gave for the descending melody for the note C sharp 3, and then for the ascending, the up melody, the rating that they gave for the note C sharp 3. You add those two probe tone ratings together, divide by 2, and you get this number 2. And you're going to do this for all 13 of the notes. I'll go through them. C natural, C sharp, D natural, D sharp, E natural, F natural, F sharp, G natural, G sharp, A natural, A sharp, B natural, and then finally C natural, but this is C natural 4 because it's the high note, it's the high tonic note. And you do this, you calculate the average of those two scores for all of the participants, for all of the notes, for all of the participants, and that's what I've done right here. And I've also shown you, these are what the answers are supposed to be. So you'll have to calculate this. If you take the average and then you highlight the entire column above it, the average probe tone rating for C natural 3 was around 5.02. And the average probe tone rating for C natural 4 was 5.42. And if you look in the middle, you can see all the other ratings are relatively lower than 5.42, which is consistent with what I talked about. The C natural, the tonic, Do, is perceived as most stable. It receives the highest probe tone ratings. So these are the things that you're going to use. These are the values that you're going to use when you're doing the one-way repeated measures ANOVA. Once again, what that one-way repeated measures ANOVA is going to do is it's going to say, among these 13 notes, A natural, A sharp, etc., all 13 of those notes, are participants perceiving these notes to vary in how stable they are? Are the probe tone ratings of those 13 notes significantly different than each other? That's the one-way repeated measures ANOVA. The quick answer is yes, highly significant effect there. So that's the repeated measures ANOVA. We also have these two t-tests that I want you to do. So the first t-test is taking the tonic notes. We have C3 and C4, and it's taking the average of them and putting them in this column for each participant. So this number right here, 4.5, let's look at the formula. AC2, AO2. So AC2 is that note 5.5. I already forgot what the other ones. And then AO2 is 3.5. 5.5 plus, what is it over here? Yeah, 5.5 plus 3.5 divided by 2 gives you 4.5. So this is the average rating that this participant gave the tonic notes. And we don't care if it was the ascending context or the descending context. This is just the average rating that those two tonic notes gave. And we're ignoring context. This is what the original authors did. They didn't care about the difference statistically between the ascending and descending context. They just wanted to compare the tonic notes to all of the other pitches. So you can calculate the average for the tonic notes for each participant like this. And then you do the same thing for all of the other pitches. So you take the average, there's 13 total pitches up here in this part right here. Starting at CN3 through CN4, there's 13 total pitches. CN3 and CN4 are two of those pitches. So right here, this is basically the average of the 11 things right here. Everything in between CN3 and CN4 is what these notes, all of the probe tone ratings for all of the notes, excluding the two tonic notes, the two do notes, the two notes C, that is CN3, C natural 3, and C natural 4. Those notes are not in here. And then you take the average for each participant, you do that. And then once again, I'm showing you the averages that are calculated right here. SPSS will calculate these again, but it's kind of nice to see what the answer is supposed to be, what SPSS is supposed to give you. So those are those right there. Finally, almost done here. It's this last post hoc test they did two post hoc tests. This is the first one. Here's the second one. The first post hoc test, they're comparing these two things right here. The probe tone ratings for all of the in-scale pitches except for the tonic. So this is, there would be, I guess there would be, so D natural, E natural, F natural, G natural, A natural, and B natural. So that'd be 6 notes. It's excluding C3 and C4. But all of the notes which are in the scale, you know, highlight that just in case. So you can see the formulas right here. These are all of the notes that are in the scale, but not the two tonic notes. And then it's comparing them to all of the non-diatonic pitches, that is the out of scale notes. These are those 5 red ones that I showed you at the beginning of lecture today. So that would be like A sharp would be an example of a non-diatonic note. All the non-diatonic notes have S's, meaning sharp, C sharp, D sharp, F sharp, G sharp, A sharp. Those are the non-diatonic notes. And so this is the, this is the average of all for this participant for all of the non-diatonic notes. That is the probe tone ratings for all of the notes that are outside of the scale. Once again, we don't care whether it's for the ascending or descending context. We just combine the probe tone ratings for those two different contexts together to get these things. And then we compare with the t-test, this column compared to this column, the means of those two columns, assuming you're using the 25 participants that I have right here, are these two numbers right here. Compare those with the t-test, these two numbers with t-test, these two numbers with t-test, and then all these 13 numbers down here, you'll come with a one-way within subjects ANOVA. So, yeah, I'll go back to the slides here. So this is what you have to do. You have to use, yeah, I said 26 scores, but actually I meant to say 25 scores. But basically you need to do the analysis with at least the 25 scores that at least 25 scores. There's that kind of like 26 where they put 2 values, but then I ended up erasing that. So you need to do all of these analysis. We're using at least 25 participants. If more people add to the Google Sheet after that, you know, like today or something, you can run the analysis with 26 or 27 or 28 participants, but you have to do it with at least 25 participants. Oh yeah, that's the 26 is for the score, the amount of scores per person. Gotcha. Okay, so yeah, so you want to do it with 25 people. These are the outputs right here. You can see this information in the video that I already posted. You see exactly how I got these things by looking at the output on SPSS in those videos. And I think, you know, let's see. Yeah, here is exactly how you're going to turn in this assignment. It's due Friday. But we're going to end class basically now. So I want you to get a good start on it today. You're going to basically take a Zoom recording of you analyzing the data. You're going to do the one-way repeated measures NOVA and 2 within subjects t-tests. And you'll show me, you're going to do that entire thing in SPSS, recording it with Zoom. And then I want to make sure that I can see your output. So scroll through all of your outputs and let me see all of your outputs. And your output should be close to this. And you'll also see the outputs that I provide you in the video. So you're going to do all 3 of those tests. Then you will save your video to Google Drive or equivalent cloud storage, create a link, copy and paste that link into a Microsoft Word document, and then you will submit it onto Blackboard. Trying to remember if I've made a place to submit this yet. Yeah, Lab 3 Part 2 is right here. So you will submit a Microsoft Word document with your video, your Zoom recording link, copied and pasted into that Microsoft Word document, and you will submit it right here. So I'm going to stop recording now, but I will be here until class leaves. I'm happy to answer questions. A lot of stuff going on in the course right now, so if you need to talk to me, help yourself catch up, I would be happy to talk with you now or schedule a meeting at a different time.